Fatigue failure analysis on SUS 304H and IN 617 welded for ultra supercritical boiler applications. This project is done by S. Dilip, R. Vishnupriyan, P. Shaktivel, and B. Mahesh Kumar, and we are guided by Mr. R. Karthikeyan, Assistant Professor Velk. The basic motto of this project is to create an perfect weld in ultra supercritical boiler applications, and which is made of Inconel 617 and the SUS 304H using the gas junction unit gas welding, and several pre-treatment and post-welding treatments are performed in order to increase the mechanical fatigue test fatigue properties. The Inconel 617 is a super alloy and made of many alloy components such as nickel, chromium, and copper, etc., which has a perfect tensile strength and a perfect heat resistant. In order to it's a high economical quality, we can't use it in all the parts of the boiler, so that the SUS 304H is used in the outer parts of the boiler, and Inconel is used inside the boiler. So in order to, we are mandatory to have a weld between the Inconel 617 and the SUS 304H, so that the dissimilar welding is mandatory in the boilers. But the present currently the dissimilar weld is not perfect, and many misalignments are coming in the weld. So that to increase the properties of the weld, we are starting the project. Before starting this project, we surveyed many papers such as Mayer et al., Cheng et al., Scrubet et al., and Mackins and Crane et al. They all studied about these weld defects and how to improve these properties of the weld, and how to change the properties of the material by adding some components and changing the creep behavior of the alloy. And the Inconel alloy 617 we took has a carbon of the 0.05%, and nickel is a measure of 42%, and iron for 3%, silicon for 0.5%, manganese for 0.5%, copper is 10%, chromium for 20%, and molybdenum for 8%, and aluminum for 0.8%. SUS 304H alloy is a common alloy, and it is used for many purposes. It has carbon 0.04 to 1%, and manganese to 2%, phosphor to 0.045 maximum, sulfur, silicon, and nitrogen. Nickel has 18 to 20% is maximum. The problems identified in the boiler tubes are stress rupture, fatigue, water side corrosion, erosion, fire side corrosion, lack of quality control. These causes the major defects on the boiler parts and the boiler failure. The basic sources of defects are tabulated here: the creep damage, thermal fatigue, high temperature damage, hot oxidation, hydrogen induced cracking, and the stress corrosion cracking, corrosion fatigue, and microstructural degradation and synthesization and embrittlement are classified there. The weld preparations before doing the welding practice, we are yet to do some weld preparations such as chamfering the ends of the Inconel and the SUS 304H tubes, and the filler rods are to be preheated by 700 degrees Celsius and slow cooled in order to have the uniform properties of the filler material. It is also done a heat treatment of the specimen before and after the welding of the furnace with the same 700 degrees Celsius, which is somewhat lower than the melting temperature of the Inconel and the SUS 304H. The pre-treatments, as pre-said, the pre-treatments are the preheating of the metal tubes to be welded at the temperature about its center pass temperature of the welding, and uneven temperature distribution and uneven crystal structure occurrence in the welded parts. The weld perimeter can be increased by cutting the tube with a 30-degree inclination, so that the weld quality is improved. The filler are heated inside the furnace, and in order to ensure the proper flow of the filler material inside every pass with the hardness assured, the number of passes in the welding process is increased to 2 times as in order to have the perfect tensile strength with the welded part. The surface tubes are to be welded is made inert to be before the welding process by the inert gases. The inert gases are generally used in the TIG welding process, and the gas used here is argon. The TIG welding, the filler rod used in the TIG welding is SUS 304H. We can also use the Inconel 617 alloy as a filler material, but in order to inadequate filler rod requirement, we used the SUS 304H. The filler rod dimensions are 2.5 dia, and 0.5 gas pressure is used, and 70 to 20 ampere current is supplied. The input voltage is 110 to 120 during the welding pass. The welding temperature is 600 to 700 degrees Celsius. We used a number of passes 2. The post-welded treatments are the material is heated after the welding process. It is reheated, and the welding parts are removed from the induced stress due to the welding. The chemical treatments are made, such as coating of chromium and etc. is done. Nickel and chromium is done in order to reduce the corrosion. Finally, the tubes are reheated to the half temperature of its melting point and very slow cooled, that is annealed in order to refine the grain structure. This is a depiction of the welding process. The fatigue failure analysis. Finally, the result of our project is analyzed by the fatigue failure analysis, and the SN curves are plotted due to it. Utilization and embrittlement are classified there. The weld preparations. Before doing the welding practice, we are yet to do some weld preparations such as chamfering the ends of the inconel and SUS 304H tubes, and the filler rods are to be preheated by 700 degrees Celsius and slow cooled in order to have the uniform properties of the filler material. Here there is the fatigue test setup, and the fatigue crack initiated is shown here. Also, the before annealing process is related to the fatigue crack initiation. It is depicted in the tabulation shown here. This is the final SN curve obtained for us. It is showing that in 275 degree 275 megapascal the endurance limit is there. Hence there is inference that the endurance test limit 260 megapascal is maintained, means the tube will have maximum lifetime, that is more than 10 power 7 cycles. It is related to 10 power 7 means more than 10 million cycles. The maximum strength of the material created is 430 megapascal, and the endurance limit is greater than 10 power 5 cycles. Okay, thank you.